Okay, today we're going to cover artificial lighting. Will be the first thing we're going to cover. And then second, we're going to cover some animation, how to set up an animation. We won't actually be rendering an animation. It takes a very long time. Essentially, 30 renderings equals 1 second of animation. So you can imagine it, so a 10-second animation is 300 separate renderings. So we won't actually be doing the rendering here. But as you've seen, there's that little sample that I made. There are some, just to predicate this, there are some companies that offer cloud rendering services. So you can basically usually they're most often priced by the amount of time it takes. So I saw one that was like 8 cents for every half an hour or every hour of rendering time, which is relatively inexpensive, considering it can save you a lot of time. An Autodesk actually offers through their Autodesk 360 program cloud services for rendering, and it's free to students and faculty. However, at this point, it's only offered for Revit and AutoCAD. I'm planning on contacting the company soon to see if they might allow something for us to use for 3ds Max. So let's get right into it. We have our pavilion. I've already put some lights in here, and I'm just going to cover how we do that again. But just for your reference, there's already lights in here. And if you remember this scene from last time, the same camera view, none of that's changed. But what I've done is I've inserted a kind of wall washer light here and a couple of can lights here. And again, we're going to cover how we actually make these and how we set up our rendering system to actually accommodate for that. So really quickly, what I'm going to do is I'm going to turn off some of the lights that we had on the last time, mainly the direct light here. Sorry, we're going to turn that off. We're also going to select the sky, and we're going to turn that off. We don't have to turn off our sky portals because the sky portals are dependent on the sky light. So if the sky light is off, the sky portals will be doing nothing. So all we have are 3 photometric lights. I'm going to turn those on, and then after we do a quick rendering here, I'll show you how we create these. These two are copies of one another, or instances of one another. Just to give you an idea of what this looks like. Sorry, open up my environment and effects. We have no exposure control. We're going to do MR, photographic exposure control, and again, we'll cover why I'm doing that later. And then we'll render. Oops, I also need to go to single. I was still stuck on the render animation. There we go. And we have an error. It also turned on our map and changed my presets. Here we go. So, sorry, I have a lot of things that are here as a result of the rendering I did, the animation. Okay, we'll see if this works. What we have, as you can see, we have a kind of wall washer light here, which is draping light over, it's a linear light, which is draping light over a surface, in this case a vertical surface. And then as this renders, you'll see 2 can lights. Which are kind of projecting light down onto the floor. And then the light from that is obviously reflecting up and bouncing off of the ceiling and the walls as diffuse light. So as you can see here, we can get some really interesting effects using different lighting types. And the one thing you have to keep in mind is that you can't just plug in an artificial light into your scene and say, okay, I'm done. Because the light is exactly that. It's only projecting light into the scene. But lights in reality are also fixtures, right? The physical objects that contain lights are part of how the light actually affects your scene. And so those things have to be modeled. And so that's where we'll kind of start. I created the Rhino model that we used to import the entire model. All I did was I opened it back up, and I amended it by creating a kind of can light. So you can see, you zoom in. Actually, this view gives it better. So this is a can light. I actually modeled this in 3ds Max, but I modeled the this light, or this fixture anyways, in Rhino. So you can see this is a mesh. And all this is a cylinder that's capped on 2 sides, and then it's got a slit opening that faces the wall. So that way I'm containing the amount of light that's actually going towards. And this is kind of what wall washer lights do. They're directional, but they're in a line. Versus the can light, which is, you can see it's hollow here. So this is a hollow opening. Can lights are more about cylinders that are capped on one side and about projecting light down. And these are kind of pendants since they're hanging from the ceiling. So this was modeled in Rhino. This was modeled in 3ds Max. It doesn't really matter as long as your geometries are all right. They're basically just geometries that contain the light that you create, right? And that's really, really important because if you don't have these, it looks like light's just coming out of nowhere. There are options to actually render the geometries of these lights. So for a point light, for instance, you can actually have it render a sphere, so you can see the glowing sphere. But if you have just this glowing sphere that's hanging in your scene, it's not very realistic, right? So keep that in mind. You have to actually model the fixtures. And in some cases, there are some companies that have already that will allow you to download their fixtures and import them directly into your model, so you don't have to model that. But I find it's relatively easy to model it myself, and you have a lot more kind of specificity over the size and scale of the object. So once you have these geometries, what we have to do is actually place lights in them. And the way we do that is by going to the Create tab on the right. We're going to pan over to Lights. And in this case, we're going to create photometric lights, not standard lights. The reason why is because these photometric lights allow us to actually have different types of projection, different types of light projection. So if you're looking at more complex lighting forms, it might be better to use photometric lights. If you're looking at very simple lighting forms, then you can use standard, but we're just going to use photometric for now. So what I'm going to do here is I'm going to move these lights that I already have in the scene. And I'm holding Control and clicking on it to select both of them, or not. What's going on here? Oh, that's not the Control button. Okay, holding Control, and then it'll select both. I'm just going to move those out of our scene for now. I just want to use them as a reference. And then I'm going to select one of them, modify, and turn that off. They're black now, which means that the lights are not active. And we're going to create again a kind of copy of those lights just so you can see the sequence of processes that were involved in creating those lights. So what I want to do is I have these can lights and I want to basically stick a light inside of them. So I'm going to create lights, photometric, and I'm going to create a free light. And what I do is I click in the top view. This is just the way that I like to do it. Click and release, and as you can see, there's a little light in our scene now. I can move it around. It's a free light, and what I need to do is position it in such a way that I know it's inside that pendant canister. So I'm just going to pull this up using the Move tool at the top with the object selected. And I'm going to place it close to the center of this canister. It's fine right about there. And anywhere up in this kind of position, we'll see the difference of the relative position of this light to the canister will actually make a difference on our scene, and I'll show you that in a little bit. But what I want to do right now is I want to modify this light. Because right now it's just an omni light. It's shooting light in every direction. And there's some really interesting things you can do in 3ds Max to kind of control that. The first thing is I have the object selected, I go to the modify list. There's a series of templates you can select, which I tend to avoid. I feel like they insert a little bit too much information in some cases, so we're just going to leave that as, we're not going to use a template right now. We're going to make sure the light is on and that the shadows are on. I'm going to not unselect use global settings, but one of the things is sometimes when you create a light, depending on your default settings, it may or may not be casting shadows. So it's a very good practice to kind of always make sure your shadows are on. Because it can be very frustrating when you put in a bunch of lights, you try to render it, and then you're wondering where all this light is coming from. It's because the light is just projecting onto surfaces, and it's not casting shadows. And I'll show you what happens as a result. So let me just turn off our photometric light 3, which is our wall washing light. And we're going to re-render this scene. There might be some settings that I might have to select, but we're going to turn shadows off for this particular light. Pushing Shift Q to do a render. And what you can see, I'm not really sure where this is coming from. It must be some animation error that I haven't deselected. Huh? No, it is, because the materials are showing up. I'll have to, we don't want to reuse Final Gather. Let's try that again. There we go. So as part of the animation we'll get to, you can reuse Final Gather, which is just your diffuse lighting, so that your calculations go faster. But what you can see here, I know it's a relatively low resolution, is that this canister is not containing the light at all. Do you see that? And that's because there are no shadow projections. The light is ignoring the fact that the canister is there, and it's pushing the light onto any surface that it comes into contact with. So, whereas if we select the light, you can also name these if you want to, and we put shadows on, then we can see, Shift Q, that now the canister is actually containing the lights, right? And now we can see, maybe we could render this a little larger. It doesn't take that long. And so you can start to see now that the canister is containing it because the solid object is projecting a shadow. Do you see the difference there? Okay. So what's interesting is that the relationship between the light and the canister actually defines this kind of spotlight here. So it looks like water here, but it's actually just a reflective stone floor. So as an example, if I move this light vertically relative to the canister, then the shadow, obviously, or the cone of light gets smaller. Right? Versus if I project the light further down, the cone of light will get larger. And you don't have to render this every time to actually see the effects, because there's a nice thing that's built into 3ds Max, where you go to lighting and shadows. Oh, sorry, we have to switch it to realistic first. So right now it's at shaded. We're going to switch this to realistic. And then we're going to go to lighting and shadows. And we're going to say illuminate with scene lights, which is already selected. Sometimes the default is illuminate with default lights. We're going to do a scene lights. And so you can see down here that as I move this light, sorry, that's the canister, up and down, that, that shadow actually changes, right? So as the light comes out of the canister is no longer projecting as much of a shadow. And so that can kind of help you in real time set up the lighting for your scene. So I'm going to leave it like, I don't know, right there. That's fine. Doesn't really matter. And then we're going to make a few more modifications. We're going to make sure that our shadows are ray traced, which means there's a hard line trace to the shadow. We're going to leave light distribution as uniform spherical. We can change the color, but right now we're just going to leave it as it is. And we can change the intensity. Right now the intensity is fine. We're not going to really change that. But what we're going to change is the shape of this light. And this is one of the nice things about these photometric lights, is that right now it's a point, but we can also make it a line, a rectangle, a disc, a sphere, or a cylinder. And this can actually be rendered. So if you want, you know, a linearly distributed light, you can actually make a linear fixture, a linear light. Right now we're going to make this a disc. And, oops. As you can see, this disc in the top view is much larger than the container. So we're going to find where its dimensions are. So the radius is what we need. Oh, and I made it sphere. I want disc. And so I'm just going to reduce the radius of this disc until it's, you know, somewhere inside that canister. The reason why this is important is because now the disc will kind of shoot light evenly down, and you can actually render that light shape visibly in your rendering. So if you look at the bottom of our canister now, you'll actually see a kind of lens, perhaps, where the light is projecting down. And then what I'm going to do is I'm going to copy that over to this other fixture that we have, and I'm going to make it an instance. So I'm going to select the object, select the light. I'm going to hold Shift as I move it, so move. And then before I actually move it, I'm holding Shift down. And I'm going to move it over to the other light. I'm going to release the mouse button, and I'm going to select Instance. The reason why I'm going to select Instance is that way if I change one light, it changes them both at the same time. If you just make it a copy, you'll have to change both lights independently, which if you really need that to happen, then you can make it a copy. But we're just going to make it an instance for this time. I'm going to zoom in and make sure it's centered within that canister. And now I have two lights in my scene. We'll render this. And so obviously under these pendants, you have pendant lights, you have hotspots where the light is most powerful, and then you have diffuse light kind of radiating outwards as a result of the canister itself. We also see that the top or the ceiling is illuminating, and that's because the light is bouncing off the ground floor and hitting the ceiling, and that's a result of our final gather calculations that are inherent into the MR renderer. Okay, so this is actually already pretty nice. I've added, since the last session, I've added a brick wall here, a black and white brick wall with a bump map, just so you can kind of see a little bit of texture in that wall, see the difference between like a reflective surface and a matte surface. These columns are projecting shadows onto the wall, and so on and so forth. But this is pretty nice already. Obviously, the rest of our scene is very dark, because we're not getting diffuse light from other directions. And in order to accommodate that, we're going to add a kind of wall washing light onto this red wall surface. I guess before we do that, let's keep running through select this light. Keep running through this modify list so we can make it a disk. We can show that shape in the rendering. We can increase the sampling size. By default, I think it starts at 16 or 32. I tend to increase it at 64. Basically what this does is it smooths out the shadows that are projected from the lights and makes them a little more accurate. And increasing it to 64 really doesn't increase the render time all that much. And just like the daylight systems that we had, or the target light, you can add atmospheric effects. So you can add volume light if you want the lights to actually have kind of volumetric projections. So now we're going to add a kind of wall washing light. And I did some experimentation with this, and what seemed the best light to do this was actually a rectilinear light, which is the same. It's a free light as a photometric light. I'm going to move it out of our scene, the one that I previously created. So you can see here's the light icon, but it's actually a rectangle, and it's projecting light from that entire surface. So what we want to do is we're going to create a new photometric light. It's a free light. We can place it anywhere in our scene. And right now, as default, it's set at a point. So it's set as a point. I want to change that to rectangle. And you can see that once I put in rectangle, it's showing a rectangular light in the top view. Obviously, that's not going to fit into our picture that we've already modeled, so I need to resize that. So in the Modify tab, I'm going to change its width to something, I don't know, like that. You can be precise with this if you want. And then I want to change its length so that it lines up relatively close to the width of our, or to the length of our fixture. What I'm doing is I'm clicking and holding on this up-down arrow, and then I'm just moving the mouse, and that can expand and contract relative distances. So that looks good right there, and then I need to actually move it up into the fixture in the front view. I'm not sure what that big circle is. Place it into my fixture. And then what I also did, basically with experimentation, I kind of rotated it so that I could get kind of a different hot intensity on the wall surface itself. And that was just kind of re-rendering it over and over again until I found something that I liked. I also, with this imported Rhino mesh, I had to do some experimenting with the size of the opening, but that's really just kind of an experiment that you can do. I want to figure out what this big circle is. Maybe it has something to do with the reflections, so we will ignore it for now. We'll go back to shaded. Hopefully it won't affect our rendering at all. So I'm going to render it again. Obviously now the wall washing light is doing exactly what I asked it to do, which is wash the wall in light. And it's pretty intense right now, and so what I want to do is kind of soften that up a little bit. And there's a couple of ways to do that. Either one, you can actually pull the light away from the surface. So, I mean, part of it is that the position of the light might be a little too close to the surface, and so you're getting these really hot spots. But there are other ways to do that with the lighting setting. So I'm going to select the light. And if I want it either brighter or dimmer, I can just change the intensity here. And this is measured in candles. Candela is candles. And if you reduce that to 500, we will see what happens. So it's a little better. I like that intensity a little more. I'll escape. And then we can also start to give it attenuation. And what attenuation is the rate of fall off between full illumination and zero illumination. And I'll show you the extreme of that, but we're going to use that right now. We'll find my light. And so right now there's two circles or two spheres. The inner sphere basically defines when the light will start falling off. So that's the point when it goes from 100% intensity to 0% intensity. And then the last one, the last sphere, sorry, reselect the light, says that's where it will reach 0% intensity. And to illustrate that point, what I'm going to do is I'm going to reduce those all the way down so that you can really see them within this wall surface. Keep in mind, light automatically over distance, it'll already start to fall off. So even if you have a light, it doesn't mean it's going to illuminate that wall evenly, even if it has no attenuation, because the distance is actually being registered and the number of photons is decreasing. But here, we'll re-render it. Oops, we're in the wrong view. Right now, I'm trying to render the front view because that's the one that's active. And so you can see that now that outer sphere, since it runs right about here, is saying that no more light is going to pass that. The light has completely diminished over that space. So if you want really harsh light like this, you can obviously make that attenuation very close to the center of the light projection. But if you want a nice smooth fall off, then what I want to do is I want to increase those numbers so that this intensity starts to fall off, maybe somewhere down here, and does so very smoothly because the far attenuation is very far away. So you can see that the intensity really starts to fall off quite quickly now that our near attenuation is actually on the wall surface. If you want that to not happen at all, then you just turn off the attenuation. You don't have to worry about it. But this, I think, gives a nice kind of spectrum of light that falls off from the wall. And you can see here that the light fixture that we have, the actual geometry is being illuminated on the inside. If I were kind of underneath this, I would actually see the interior of that fixture, the inside of that, glowing very brightly. And so with just 3 lights, we can actually get a really interesting kind of lighting condition, interior artificial lighting condition. You can do this, like if you said, well, I don't like how dark this space is underneath here, then what you need to do is put a light behind the camera in order to project kind of diffuse light. Or let's say this is in a really dense urban environment and there's light coming from the actual windows. Then what you can do is, just like we had a daylight system or a skylight system before, you can turn the skylight system back on, but take the multiplier way down and maybe change the color so it looks a little more artificial, and you'll get kind of a diffuse light in through the windows. Okay, so the last thing we'll do with artificial lighting is we'll show the effects of color change. So let's say this is a nightclub, and we want to do some radical colors. Name a color. Who's got a favorite color? Purple. Is this purple enough, or do we want? Yeah, it's kind of pink, isn't it? There we go. So we'll do some purple lights. And if I change one, since they're instanced, it changes them both. We'll re-render this and see what happens. Oh yeah. But just to kind of show you the effects of establishing color. This is the extreme, but there's a big conversation going on right now with LEDs, that the color of the LED, and it's getting better and better, but the color of LEDs and some compact fluorescents doesn't meet the color quality of incandescent lights. People like this warm color. So if we do something really subtle with these lights, you can kind of change the quality of the scene. Maybe that wasn't enough. you can kind of change the warmth of the color of the scene based on the color of the light. So if you're finding that it's too cold or something like that, you can increase the color of the lights to get more warmth. Optionally, you can also change the materials that are in the scene, which reflect color into the scene. So right now, this brick wall is a black and white, no color brick wall. I used the bump map twice, essentially. If it seems kind of sterile, you have options. Either you change the material itself, or you could change the color of the light. You guys see the difference between how it's kind of a little more yellow, warmer now? Good. Okay, so that kind of covers artificial lighting. Remember, it's almost more about the fixture than it is the light itself. Architecture, nothing in architecture has I should say it this way. Everything in architecture has a dimension. It has thickness. All materials have thickness. Some of them are very thin, some of them are very thick, but they all have thickness. And so you should really treat your models that way, so that you kind of represent it in a way that's useful. And lights are not infinitesimally small, they're objects. And so you need to, just as you're thinking about how the light is actually projecting into the space, you have to think about through what means, and model it, make it yourself. Okay, so what we're going to do now is we're going to turn off those artificial lights. We're going to turn back on our daylights so that the render times are a little faster. Obviously, the more artificial lights you place into your scene, the more calculations that have to take place, which means your render times are going to be longer. So I'm going to hit the letter H, which brings up our select by name. I'm going to turn off our can lights. I'm going to turn off our wall washer. And then I'm going to turn back on our skylight. Turn back on our direct light. You can also obviously save like two different models. If you want to have one model that's for daylight settings and one model that's for artificial lighting settings, that might be the easiest way rather than going back and forth and turning on and off lights. Because now in addition, I have to go back to our render setup. Our environment and exposure. I'm going to change this to no exposure control. And I'm going to turn, I think we turned on our skylights, right? Yes. So now if we re-render this, should bring us back to something that we're familiar with from the last session. I've turned off volume light too, because volume light increases the render time. And what we're going to do here is we're going to animate the camera as though it's kind of walking through the scene. And I've already done this with another camera in this scene, so I'll show you what happens. So we're going to start with camera 2, which previous to this session I've already animated. And I'm going to run it through the series of frames at the bottom. And I'll go over all of this interface with you in a moment. As you can see, as I start to move this slider through, it's actually moving the camera. You can see it in the top view as well. And so literally what you're doing is you're telling 3ds Max through a series of frames where it should place these different objects or how it should treat them. And that's what we're going to do. But we're going to do it with camera 1, which isn't animated yet. And so first we'll cover the interface. So at the bottom, like we said in the first session, this basically controls all of your animation, not all of your animation components, but kind of helps organize them. And it starts at the bottom right, we have time configuration. And this is where you control the length of the animation. There's a lot of things embedded in here which I'm not entirely familiar with, so the only thing we're really going to change is the start and end time of the animation. As default, the animation is set to 100 frames. But keep in mind that right now, the FPS, or the frames per second, is set at 30, which means for every second of animation, you're rendering 30 frames, 30 individual images. So that is how you kind of scale the length of your animation. So if I move something between frame 30 and frame 60, that is 1 second of animation duration. Is that clear? So right now, the start time is 0 and the end time is 300, which means this is a 10-second long animation if you were to render all 300 frames. So I'll say OK. I changed that earlier from the default, which is 100. And that number of frames is represented down here as a kind of timeline from 0 to 300 and all of the frame increments in between. Obviously, the resolution of the frame increments here is dependent on the entire length of the animation. Under that, you have the kind of keyframes, and I'll show you what that is in a minute. And then you have relative positions of objects you might be changing or have selected. So the way this works is that you kind of move this slider along to select the frame, and then what you do is you key in objects to be in a certain position at a certain time. So we're only going to move the camera and its target for this animation, but this applies to objects, it applies to lights, it applies to the settings of those lights and objects. So for instance, you can change the intensity of a light over time so that as it animates, the light gets brighter and brighter and brighter, or darker and darker and darker. And the way you do that is by setting keys. So there's two settings here. There's set key, which is a manual way of doing it, and there's auto key, which, as it implies, automatically sets the keys for objects that you move. I find that auto key takes too much control out of my hands and tends to do things that I don't always want it to do. So I always do it manually in set key. So what we're going to do is we're going to select the objects that we intend to move, and those are camera 1, and I'm holding down control, and its target right here. These are the only two objects we're going to be moving in the scene. They don't affect the lighting, so anytime you're moving a camera, it's nice because you don't have to recalculate the diffuse bounces or anything like that, so you can reuse those maps. But if you were to move objects, or you were to move lights or change light settings, those actually affect how light is bouncing around in the scene, and so that would require more accurate final gather calculations. So what we're going to do is we're at 0 frame, and we have these objects selected. I'm going to select set key, and you'll notice that this bottom bar turns red. That's so that you know you are in set key mode. If you don't have this active, it doesn't matter how many times you push this little key, it's not actually going to set anything. But if you have it active, anytime you push this key, it's going to set objects to a particular position within the animation. And what I tend to do is I select the objects I'm going to move, and I'm going to push the key, and you can see right over here there's a little box showed up. Those represent the objects you have selected, and it's telling you, what it's saying is you're telling 3ds Max that at frame 0, camera 1 and its target should be in this location. Okay? I'm going to move this slider up to frame 30, which is 1 second after the animation begins. And I'm going to key it again, and I'll tell you why. So now it's saying, okay, now between 0 and 30, the camera and its target are not moving. And the reason why I do that is because depending on how you want to set up the animation, it's very uncomfortable to start an animation and have it immediately start moving. So if you notice in the scene that I animated before, there's a little pause, and then the camera starts moving. That allows the viewer, mainly you guys, to kind of get situated with the animation or the scene before it actually starts. Alternatively, you can do this in Adobe Premiere, as a post-processing, where you take the first scene or the first rendered frame and you just extend it out over a period of time, and then the animation starts. But it's just a kind of good practice. I tend to do it this way. The inefficient part of this is that you're basically rendering 30 scenes where the camera's not moving at all. So if you intend on post-processing through Adobe Premiere or another movie editing software program, then you can start immediately into the animation. So now what I'm going to do is, and I haven't really thought about how we might move this camera around right now, but we'll just move this camera from this side to the other side of this little courtyard. And so I'm going to move it, I'm going to say maybe the first 2 seconds. So I'm going to go up to frame 90. The first 2 seconds are going to be moving the target so that my camera starts to look down this corridor. And I'll start to move the camera itself a little bit. And now I'm going to key those back in. So I'm going to select, I have the camera selected now. I'm going to hold control and select the target. And I'm going to key those in again. So now it's at frame 90. 3ds is interpolating the movement between where it was at frame 30 to frame 90. I'm then going to slide again another 2 seconds maybe. So we'll go to 150. I'm going to now kind of move the, oops. Move the camera down this corridor. Move the target kind of around to maybe this bench. Or maybe a little further. There, that's fine. I'm going to select them both again. And I'm going to set that key. And then another couple of seconds will go by. Doesn't really matter where. And we will move this camera like that. Select. Oops. Key that in, and then we've got some extra time. You can always just render, frames 1 through 220 if you want. I'll show you how you do that. We're going to unselect set key, and now as I move this frame, it's actually showing this animation, right? So it's saying between 0 and 30, the camera's not moving. That's 1 second of animation. Between 30 and 90, the camera's moving like this, and so on and so forth until its final position. We can also animate that in real time by pushing the play button. Oops, we're in the wrong view here. And you can see that this is the real-time projection of what our animation will become. So if you don't like how fast something is moving, you just have to rekey in those objects, right? And it just plays on loop until you pause it.
Can you show how to unkey something?
Yes. So once you have set key in, if you select the objects, I really moved the, you can see that if you select these keys themselves, you can actually delete that particular key. And it only deletes that key for the objects you have selected. So I could, if I select, I have camera 1 and its target selected. Okay, I can select that key and delete it by pushing the delete key, and it will get rid of those keys for only the selected objects, which means if I have other objects that are keyed onto that location, like camera 2, for instance, it's not going to affect that animation at all. The real thing, the tricky thing you have to keep in mind is that if you delete a key, 3ds is still going to interpolate between, so let's say I delete this key right here, 3ds is still going to interpolate between this key and this key. So it doesn't mean that your animation just stops moving at that location. You're going to have to reset that key sometime. Does that make sense?
Change the location also?
Yeah, you can slide it this way so that that movement takes longer. So let's say, here, we'll show what that is. So now the movement between this set key and this set key are much longer, but the movement between these keys is very fast, and you'll see that change in how rapid it is. Wrong. So slow movement, and then boom, right? Because we moved that set key, and then this one takes a very long time to actually. Do you like my vocal annotations? So alternatively, we can take this and we can just move it so that that movement is particularly long, depending on how fast or slow we want the camera to move at that particular time. Remember, it's always dependent on the objects you have selected. The only keys that will show up are the objects that you have selected, which means if I have only the camera selected, the target for that camera will be moving as always, as normal. It won't change that. So you can move them independently. So that is how you set up an annotation or an animation. You can see that both of our animations are still here, right? Both cameras up in the top view are still moving because we didn't affect camera 2, which is the one I animated previously. Camera 2, which I animated previously. So you can have multiple animations or multiple things moving. And since these are cameras which don't actually affect the scene, you won't have to actually change any of the lighting settings or something like that. So just as we're not going to finish this rendering, but just as a representation of what that looks like, because you have to change some things here, we're going to run through how you set up the rendering settings and some really nice things that 3ds can do for you. So if we open up our render settings in the rendering tab, this is the last thing we'll do. What we have to do is, right now it's on single output, which means it's only going to render the frame that is showing up right now, or the frame that you have selected. What we want to do is we want to do either active time segment, which will render all 300 frames, or we can select a range from 0 to, what did we have, 220 or 240 or something like that. And now it's saying, okay, you're going to do an animation. And if you just hit render right now, it's probably going to prompt us. It's going to say you can't do this because there is no assigned file to save to. So what we have to do is we have to say, well, we have to save this to a file. You have to select somewhere within the computer. We will say new folder, animations, and we'll do tutorial tests, and we're going to save it as an AVI file. It's a very common type of movie file. We're going to keep advanced lighting on, and we're also going to compute advanced lighting when required, because if you're not changing the lighting settings, then the amount of changed advanced lighting calculations that you have to do can be minimized. You don't want to have to, essentially, you don't want to have to calculate the diffuse balances every single scene. There's too much redundancy. We're going to lower this to its lowest settings here. We're going to have final gather at draft. We're also going to come down here, and we're going to keep this at single file best walkthrough for stills, but we're also going to go incrementally add FG points to FG map files. And what that does is that instead of trying to recalculate the final gather points every single time, it does it very incrementally. So it's small changes over the whole animation rather than trying to recycle it every single time. We will push Shift Q, and we're in the wrong scene. And this might be map file. Not entirely sure why that's coming up. Make sure we have this. So we're going to overwrite that original file still. Sure. That scene is active. Great. Yes. There we go. And so you can start to see now it's rendering this scene, and that this is 1 out of 241 renderings that it has to do, right? So we could say, well, it'll tell you the elapsed time after every new frame. "27 seconds. So it's 27 seconds per frame. So if you multiply that by 241, that'll give you at least an estimation of what the animation is going to take. Obviously, the length of each frame is dependent on whatever materials are in the scene, how much light is bouncing, so on and so forth. So every frame isn't going to take exactly 27 seconds. But every single frame has to be rendered, and you're going to render 241 of them. Okay, so keep that in mind. It takes a long time to do, and this is even very low quality. You have a question?
Yes, I answered it. But with a camera, rather that frame over and over.
Exactly. So right now, 0 to 30 is part of the animation. This is why, if you don't want to have to render those first 30 frames, you can always do that in post-processing. But you never want to have an animation that just starts moving right when it opens. It's very uncomfortable, actually. You're kind of watching, and all of a sudden, someone pushes play, and the scene's already moving, and you're like, whoa, what's happening, right? It takes a few seconds to actually ground the viewer into the scene before the camera should actually start moving. You can do that either through the scene itself, the animation, or if you're familiar with programs like Premiere, you can just take that first frame and extend it over a period of time. Any other questions? Yes?
About moving objects or moving light.
It's the exact same thing. So the cameras are just like objects, except they're invisible objects. So if I wanted to move this bench, for instance, I would just select the bench, I would key it into a certain frame, I would move it within the scene, and then key it again a little while later, and we could have this bench floating in the air or something like that, right? Same thing with lights, but keep in mind when you change either solid objects in the rendering that affect lighting, that means you're going to have to recalculate the the final gather settings every time, right? Because it's going to actually affect the lighting in the scene. So right now, I keep saying figure ground, the final gather, maybe because this lecture we had yesterday, the final gather takes almost no time at all to calculate. This is actually just the rendering part of it. So it says current task rendering. Now watch when you go to the next frame, the final gather will happen almost instantly. Boom. And the final gathering is done. And that's because it's not redoing the final gather every time. It's only making incremental changes because it doesn't have to change it every time. Because nothing in the light in the scene is actually changing in terms of lighting or geometry. So if you're just doing a walkthrough, then you can it can be a little faster. But if you're making lighting changes, like if you were simulating how the sun was moving in the sky or something like that over a period of day, you wouldn't be able to. You'd have to recalculate the final gather every time, which might take a little longer. And we're getting some kind of really strange lighting here, and that's probably because the settings are so low. Any other questions? We'll escape. You can also set it up in the render settings to save automatically. It'll automatically save when it finishes. You can also set up email notifications. But if you cancel it early, the animation still saves. Oh, you know what? I might have written over it. Yeah, I did. So the animation still saves, but we only had like 10 seconds, like 10 frames there, so it was less than a second. And I accidentally saved over the old one. But so let's say you get 200 frames into a 300 frame rendering. If you cancel it, you'll still have those 200 frames of animation, which means you can go back later and render the last 100 and then just splice them together in a movie editing program. Yeah. Mm-hmm.
Say you're saying maybe you're in nighttime rendering somewhere where you're going to have the camera really far away from the
Okay.
What sort of settings would you have to so that light actually makes it all?
Sure. The question was, just so we have it recorded, if you do nighttime rendering outside of a scene, very far away from a building, for instance, are there any settings you might have to change in order to have that light actually meet the camera? The answer is kind of yes and no. No, because if the light doesn't hit an object, you're still going to be seeing the light through the atmosphere, or through the space in between the camera in the scene. So it doesn't matter how far I am. I mean, there's no night time, but if I'm like really far away and the model is very small, I'm still going to see the illumination. It's still going to reach the camera. It's really more a question of intensity. Is it bright enough or not? So the no part of that is you may have to change the intensity of the light if you want the light to actually project further out of the building. Does that make sense? But the light will always, I guess I mapped. At some point I accidentally mapped that. So I'll just to satiate your appetite for answers, we'll turn on some of these photometric lights that we have inside. Have to go back. This is why it's usually nice to and render this view. And so you can see some of the lights projecting, well, maybe you can't, but there's some lights projecting out of this. Obviously, I only have 3 lights, and they're not necessarily next to transparent parts of the building, but you can see them projecting out. So if I change the intensity, the only thing that's going to change is that they'll get brighter. So I still see them, but they're just maybe either dim or not as bright as you want them to be. Does that answer your question? Great. Anything else? Okay. Oops.